Welcome to the channel. In this video, we are going to make a planetary gear drive assembly with the help of SolidWorks toolbox and also perform motion analysis. So let's get started. Go to File, click on New, make sure you select Assembly, click OK. Now select the front plane, cancel this thing. Go to the Sketch tab, select the front plane, click on Sketch, click on Circle and draw a circle from origin of 200 mm diameter. Again click on Circle, draw a circle of 100 mm diameter. Take a line, make sure you start it as for construction. Keep the dimension of the line as 75 mm. Take the circle and draw a reference circle of 75 mm radius. Make sure you click for construction. Now, as we are going to use 3 planetary gears, we have to make 3 reference points on the reference circle. To do that, select circular pattern, make sure this number is 3, click OK. These 3 points will be the primary locations for our planetary gears. Exit the sketch. Now we have to create reference axis for all the gears in the assembly. To do that, go to Reference, click on Axis, which is available in Assembly tab. Then click on Front Plane and select a point upon which you want to create a perpendicular axis through. Click OK. Make sure you follow these steps for all the points on which you want to create an axis and place the gears. Now we have these 4 axes which will act as a reference for all our gears. Now we have to use the design library toolbox to make our gears. Here the SolidWorks toolbox is not added. Make sure you add this. It will take a while. I'll get back to you when it's done. Now as you can see, the toolbox is added. If you do not find the toolbox, you go to the add-ins and make sure you have added SolidWorks toolbox library. Now in the toolbox, scroll down to the ISO folder. Again scroll down, go to power transmission, click on gears and drag and drop a spur gear on the screen. Now as you can see, a configure component box has opened where you can change the settings or configurations of your part. Select the module as 2. and select the number of teeth as 50. This is the size of our sun gear. Make sure you select the face width as 15. This will increase the thickness of our part. Keep rest all settings as same. Click OK. Now again go to the design toolbox. Drag and drop a spur gear on the screen. Again, a configure component dialog box will open. Keep the module as same and reduce the number of gears to 25, half of what the sun gear has. As we want 3 planetary gears, also make sure the face width is 15. Now as we want 3 planetary gears, place 3 of them on the screen at different points. Click on cancel. It's time to transfer our ring gear into the assembly. To do that, follow the same procedure. Go to toolbox, select this internal spur gear and drag and drop it on the screen. Configure the component as follows. Keep the module as 2 and keep the number of teeth as double of the sun gear, that is 100. Make sure the face width is 15. This will increase the thickness. Click OK. As you can see, we have all the necessary gears to create an assembly. Now as you can see, the body thickness of this ring gear is very small. So we need to create a body above the flat surface of this ring gear. To do that, I did the part which will make it open separately in a different window. Now we need to create a sketch on the front plane. Click on the sketch tab, select the front plane, click on sketch. Get the face, sketch the normal direction. Draw a circle equal to the outer edge of this ring gear. Click OK and exit the sketch. Now go to the Features tab, click on Extruded Boss and make sure you select Thin Feature. We will have a body which is attached to our ring gear, which will increase the body thickness of our ring gear. Make sure you select the direction 1 as through all. Click OK. Now we have a ring gear with appropriate thickness and we can now assemble it into our assembly. Also make sure to delete the mate reference as it will create problems while saving the document or the part. Now save the document and save it into a desired folder or your principal directory. I have it on my desktop. Now close the sketch and you will see an updated assembly. Here we are. We have all the appropriate gears with perfect dimensions. So let's assemble them. Now make sure that our sun gear is floating. To do that, right click and select float. Now our sun gear is free to move. Select mate, select the axis 1 and this face of the sun gear to align it with axis 1. Click OK. Now select this face and the front plane to align the sun gear with the front plane. Do the similar process for all the other gears. Select this face and the axis 2, click OK. Select this face and the front plane. Similarly, select axis 3 and select the face of this planetary gear, click OK. Select this face and the front plane. Select this face and axis 4, click OK. Select again the face and the front plane. Now select the outer body of the ring gear and axis 1. Select this face and the front plane to align it with all the other gears. Select OK. Now you can see our assembly is done. Now match the components properly with each other. As you can see, each and every component is matched perfectly and our gear assembly is ready. Now we have to define the gear ratios of all the gears in the assembly. To do that, go to Mate, go to Mechanical Mates, click on Gear. Now select this face of sun gear and the planetary gear. You can see the number of teeth. Change the number of teeth of sun gear as 50 and for the planetary gear as 25. Click OK. Follow the same procedure for other gears. Select both the faces. Make sure you select gear in the mates option and define the teeth as 50 and for planetary gear as 25. Do the same for the third planetary gear. Select both the faces. Define the sun gear teeth as 50 and planetary gear teeth as 25. Now click on this face and the ring gear. Make sure you select the gears option from the mate. Do the same procedure. Define the planetary gear teeth as 25 and the ring gear teeth as 100. Click OK. Change the view to the front view. Now let's check whether our mates are properly done and the assembly is working properly. To do that, go to Move Component, and select a ring gear. Now drag the ring gear and you will see we are able to move each of the component and all the gears are rotating perfectly. Rotate the assembly to have a better view. We can see appropriate mashing of gears and our assembly is working fine. Now let's edit the appearance of gears in the assembly. To do that, click on the first gear and click on Appearances. Click on the first option. An Appearance tab will appear. Go to Color. Select the color you want. Keep it as blue. Click OK. Now select the multiple gears that are our planetary gears and edit appearance. Select the first option. Keep the color you want. Just keep it gray. Click OK. Similarly, change the color of the ring gear. Select the color you like. Black and click OK. Now as you can see, our assembly is ready. Hide this. Let's start with the motion analysis. To begin with motion study, first of all, make sure you hide this sketch. And click on the motion study tab here at the bottom of the screen. Now go to SolidWorks add-in and start SolidWorks motion. By starting the SolidWorks motion, you will have an extra option of motion analysis. If you do not start SolidWorks motion, you will not have this option. Now let's give the assembly its motor driven part. We will select the sun gear as our motor driven part. Right now it's in the anti-clockwise direction. Give the RPM as 20. The minus value won't work. You have to change the direction from above. This will make the rotation in clockwise direction. Increase the timeline to 6 seconds. Now select contact. Select the whole assembly. Click OK. This will generate contact between each of the mates and the components. Now click on Calculate. It will take some time and the assembly will start on rotating and calculating the preferred motion that is obtained through mates and the components. As you can see, we are able to have a good motion of 20 RPM between all the gears. As the calculation is finished, make sure you play it again to see the smooth motion between the components. Rotate the view to have a better idea of the animation. Now play. So this is our planetary gear drive assembly with motion analysis. If you learned something, hit the thumbs up and subscribe to the channel.